So this problem we're going to look at when given the velocity of some object. In this case, it's just a particle moving, looking at the velocity of a particle moving. We want to find the displacement and the distance that it travels. Now the difference is the displacement is just the net change that we've been looking at all along. So to find displacement, we're not going to do anything different than we've already done. To find the distance, however, we actually need to find the total change. So in this problem, I've graphed this function for us. Now we're only concerned from 1 to 4 seconds. So we're only concerned from this time from here to here. Now if I highlight what's happening here, the area from about 1 to 2 seconds is underneath that curve. That's going to mean that this area is all going to be negative. I'm sorry, I said 1 to 2, but that's really 1 to 3 seconds. From 3 to 4 seconds, you can see that the area is going to be above, giving us a positive area. Now for displacement, I'm not worried about my positive and negatives. I simply am going to integrate the function from 1 to 4, t squared minus t minus 6 dt. Now what's going to happen here, you can see that the majority of my area is negative. So I should get a negative result when integrating because I'm just simply looking for that net change. So I find that antiderivative, t cubed over 3 minus t squared over 2 minus 6t. And I'm going to run that from 1 to 4. So very quickly, when I run my 4 through the function, I should end up with negative 10 and 2/3. And then when I run my 1 into the function, I'm going to have minus a negative 6 and 1/6. So when I subtract that negative out, I'm going to end up with a change of negative 1.5 meters because we started out at meters per second. So we're looking at a difference of negative 4.5 meters. For our second part of this, we want to actually find what the distance is traveled. So we're looking for that total change. How far was the distance from 1 to 3 and then added to the distance from 3 to 4? So what we're going to do is we're going to integrate this function again, but we want to integrate the absolute value of this function, because we want to take that big negative orange piece and we want to make it positive. So we've got to actually figure out where does it hit the x-axis. So the first thing I'm going to have to do, now we can graphically see that on here, but just so we're walking through all of the pieces to this, I want to first figure out where this function is negative and where it's positive. So I'm going to set it equal to 0, and I'm going to factor this very quickly. T minus 3, t plus 2 equals 0. So I know that my function is going to equal 0 at negative 2 seconds, which doesn't make sense for time, and at 3 seconds. So what I have to do, just like I did before, if I don't have that graph available to me, I need to see what is my positive piece and what is my negative piece. I know 3 seconds is where it hit 0. So I'm going to test this. I'm going to test from 1 to 3, and then I'm going to test from 3 to 4 and plug that value into that function and see what actually gives me a negative value and what gives me a positive value. When I do this, I find that negative piece shows up from 1 to 3, and the positive piece shows up from 3 to 4. So when I go to integrate this function, or the absolute value of this function, I'm going to break it up into 2 pieces. I'm going to first integrate the negative value from 1 to 3. Basically, you can just integrate this normally and then negate this piece. plus, then I'm going to integrate from 3 to 4 regularly. Now, you don't have to redo the integration. We've already done the integration up here. It's just a matter of running it from our new n values. So I'm going to integrate. I'm going to get t cubed over 3 minus t squared over 2 minus 6t. I'm going to integrate that from 1 to 3, but I've got to negate that piece. And then I'm going to add that to, again, it's going to have the same integral, but I'm going to run that from 3 to 4. So when I run all these numbers, this is where you've got to be real careful because you're going to have a lot of values going on because you have to plug in your f of 3, your f of 1, your f of 4, your f of 3. But after you do all of those calculations, you should end up for the first piece, when you get your negative value, you're going to get a negative 7 1/3, but you're going to negate that, and this is going to give us 7 1/3. For your second piece that you're going to add to that, you should end up with a 2 5/6. So the total distance traveled by that particle is 10 1/6 meters. You can see that the displacement, it moves more negatively, but the distance total should always end up being positive when you are done.